Hello students, welcome back. This question is from GATE 2011 exam. Now if you have a look at the statement of this question, it's a really lengthy one. You'll feel as if this question will be very difficult. But once you have a look at the solution to this question, you'll say that this one was the simplest question to be asked in this topic of computer architecture and organization. So what we are going to do is we'll not read the entire statement. Instead, I'll explain you whatever they are saying in the question. Okay. Then we'll have a look at the solution. So question says, whenever some device, IO device, wants to transfer data, CPU executes this program. This is the first method of transferring data. So there's some ISR which is executed. They also have specified one more method of transferring data, which is using the DMA controller, or commonly known as DMA. What happens in DMA is 20 cycles are needed initially to just set up the DMA. That means initializing count as well as the address register. 20 cycles are needed initially before transferring any data. Also, after that, each byte will take only 2 cycles to get transferred. What will be the speed up? I've written the formulas here. Okay, we'll talk about this later on. Now, they're also specifying that for executing this program, each and every instruction will take 1 clock cycle except for load and store. Okay, so they're specifying if you execute this program, how many clock cycles are needed, and if you use DMA, how many clock cycles are needed, what will be the speed up. Now you very well know speed up is time taken by non-pipelined processor divided by time taken by pipelined processor. Also, there are few other formulas for calculating speed up. It's actually just dividing the old designs time by new designs, or old approach divided by improved approach. Okay, so old approach is this one because it will certainly take more time because it has a loop which is of 2 plus 2, which takes a lot of cycles. Okay, DMA takes only 2 cycles for transferring 1 byte. So DMA is the improved version. That means you need time taken by old design, which is this one, divided by time taken by new design, which is DMA. Now DMA initially needs 20 clock cycles and then 2 clock cycles are needed for each and every byte. Total 500 bytes needs to be transferred. How many clock cycles will be required? That is 1000. Okay. So DMA requires a total of 1020 clock cycles. That means denominator will be 1020. Let's find out the numerator, time taken by old design, this one. So let's just see. First, understand this program. Let's see what they're trying to do. Initializing the address register, initializing the count register. That means wherever in main memory you want to save your data. For example, say this is the main memory. You want to start saving from address number 10, address number 100. That means whatever the device, IO device will transfer, it will be saved at address number 100, then 10110, so on 500 addresses will be occupied. You are initializing the address 1000 into some register, called the address register. Then you are initializing count, which is equal to 500 because you want to transfer 500 bytes. Now what is happening in this loop? Load a byte from device, that means take a byte, save it, store in memory at address 1000. That means fetch a byte, save it at address 100 or the address pointed by the address register, which obviously is 100. After that, you increment this address register because we have written a byte here. This is done. Now make it, say this one is the address register. Earlier it was pointing to 100. Now it will point to 101. That is increment address register. Then they are saying decrement count. Now first byte is done. We will be left with 499 bytes. So this value will be decremented. Okay. So on, you just keep on transferring bytes one by one, one by one, one by one until count becomes 0. Certainly when you keep on decrementing this count, it starts from 500. It will become 0 eventually. After the count will become 0, you will get to know that 500 bytes are done. The entire block that we wanted to transfer has been transferred and we can stop. So if count is not equal to 0, that means there's some positive value in count. You will keep on repeating this process. As soon as count is 0, you will just terminate the loop. Okay. That is how data is being transferred. Even though it was not actually required, still I explained it. Now let's see how many clock cycles will be required. They're saying, except for load and store instruction, each and every instruction will require 1 clock cycle only. So clock cycles required by this instruction will be 1, here also 1. After that, load and store, both of these will require 2 clock cycles each. So 2 here and 2 here. Then these are just operations on registers. Both of them will require 1 clock cycle. Also, if count not equal to 0, go to loop. This one is a branch instruction. That too specifically a conditional branch. Anyways, they are mentioning that only load and store instructions need 2 clock cycles. So they will obviously take 1 clock cycle only. Now see, these 2 clock cycles, they are just for initializing. Okay, they'll not be looped over again and again. That means this 2 will be counted only once. After just executing this program till here, you'll loop on these lines only. That means from here to here, which means all these clock cycles will be counted for 500 times. Let's see how many are they. 2, 4, 5, 6, 7. Which means the total number of clock cycles required by this program will be 2 plus 2 clock cycles for initialization plus repeating this entire process from here to here 500 times. That is 500 into 7. These are 7 clock cycles. 7 5s are 35. So this one will be 3500. 3500 plus 2 is 3502. Okay. That means this formula, now we can just substitute the values in this formula. Time taken by new design is 1020. See, time taken by new design is 1020. Time taken by old design is 3502. 3502. This is the answer. That's it. Now, even though I took a lot of time, that's because I wanted to explain you each and everything. Had you been solving this question, that too in GATE exam, it's just like 30 seconds to 1 minute maximum. So let's just divide it. This one will be 3 point something. 3502 divided by 1020. 3.43333. So the answer is 3.43. Answer to this question is 3.43. Now, I'll again display the statement, or maybe let's just read it. Probably we haven't missed any important point.